Hi students, today I am going to explain for 10th students carbon and its compounds. So we will learn about carbon and its compounds today. So in the last chapter we came to know about many compounds which are very important. In this chapter we will read about some more interesting compounds and their properties. We will learn what is their significance in its elemental form and also in a combined form. So look at the items you come in the last column of the above table. So we have so many of things made of metals, glass, clay or others. Metals like so many things like vessels, so many tables, and glass and clay, window lanes, so others. So in all this we are able to tell most of them are made up of carbon compounds. So we can think of a method to test this. What will be the product if a compound containing carbon is burnt? So when we burn a carbon compound, what we will get? So we can test like this, and we can test to confirm that also. Then food, clothes, medicines, books, or many of the things you listed. From this we can know that the versatility of carbon. What is versatile element? Why it is called versatile element carbon? Because it may exist in so many different forms. So that is the meaning of versatile. So many different forms of carbon it exists. In addition, in all the living structures also carbon is present. The amount of carbon present in Earth's crust and in the atmosphere is quite meager, means only very little percentage of carbon is present on the Earth's crust and also in the atmosphere. But still it exists in so many forms. The Earth crust has only 0.02% carbon in the form of minerals like carbonates, hydrogen carbonates, coal, petroleum, and also in the atmosphere it is only present as 0.03% of carbon dioxide. Though it is present in very small amount, carbon available in nature, it is very important and it seems to be immense. So what are the properties it makes it more important? Let's see how is the bonding in carbon. So it is called covalent bond. So what is ionic bond, covalent bond? Let's see. So ionic bond have high melting and boiling points. Ionic bonds or ionic compounds are formed by transfer of electrons. As we know, the electrons will be transferred in the ionic bond, and that's why they have high melting and boiling point. It's not easy to melt or boil them, so they have more boiling and melting point. And also, as ions exist in positive charge and negative charge, they can conduct electricity in a solution or in the molten state. We also see the nature of bonding and ionic compounds explain these properties. So, but here we will see about carbon compounds. But carbon compounds are poor conductors of electricity. From this we can understand they are not forming ionic bond. But what type of bond is present in the carbon compounds? Let's see. See the acetic acid melting point and boiling point, ethanol, chloroform, methane. They gave in the table. So from this table we find that these compounds have low melting and boiling point compared to ionic compounds. So from this we can conclude that the forces of attraction between these molecules are not very strong forces. They don't have that much strong forces. With a little melting temperature and with little boiling temperature only, they will get boil easily and melt easily. So and they are also non-conductors of electricity. They don't have charges. That's why they cannot conduct electricity. From this we can conclude that bonding in the compounds do not give rise to any ions. It will not give any ions. So in class 9 we learnt already what is valency. It is a combining capacity of an element, and it depends on the number of valency electrons. So number of the valency electrons, so that will be its combining capacity to form the compounds. And we know the electronic configuration of carbon. So when we see the electronic configuration of carbon, so carbon, its atomic number is 6 we can write its electronic configuration as 2, 4 in the K shell and L shell. So we can see here 4 electrons are there. To obtain octet state, we want one more 4 electrons to become, we know what is octet. It should be 8 electrons should be there in the outermost shell so that it will become octet. To obtain octet, it should want 4 electrons. So its valency is 4. It may take 4 to become 8, or it may lose 4 to become 0. These two are the stable structures. So the valency is 4 whether it loses or gains. So we can see here. So now let us look at the electronic configuration of carbon. I already told you. Atomic number is 6. So what would be the distribution of electrons in various shells of electrons? We already told 2 in the K shell, 4 in the L shell. Then we know the reactivity of explained as the tendency to attain a completely filled outer shell. So that is completely filled is 8 to attain a noble gas configuration. So elements forming ionic compounds achieve this by either gaining or losing electrons from their outermost shell. In the case of carbons, it has 4 electrons in the outermost shell. I already showed you. And it has to gain or lose these 4 electrons to attain the noble gas configuration. So if it gains, what happens? If it loses, what happens? Let's see. It could gain 4 electrons. So to form C4 minus anion, but it would be difficult for the nucleus with 6 protons to hold on to 10 electrons. That is 4 extra electrons. If it gains, what happens? It should bear 8 plus 10. So 10 electrons it should hold. It will become very difficult to hold the 10 electrons because of this 4 extra electrons. That's why if it loses 4 electrons, what happens? It will become C4 plus anion, but it would require a large amount of energy to remove 4 electrons. Here what is the difficulty? If we gain the electrons, so to hold 10 electrons, it will become very difficult because of the 4 extra electrons. But if want to lose the electrons, it also wants more energy to remove the electrons. So leaving behind a carbon cation with 6 protons in its nucleus, holding on just 2 electrons. So if this 4 is gone, then it will have only 2 electrons. So having only 4 protons holding only 2 electrons. So carbon overcomes this problem. So how it can do? If it loses or gains like this, it is difficult. So to overcome this problem by sharing these valency electrons with other atoms of carbon or with other atoms of other elements, so it no need to lose or gain. It will just share. Remember this. So not just carbon, many other elements like this share electrons in this manner. The shared electrons belong to the outermost shells of both the atoms. Both the atoms will have that electrons leading to a inert gas configuration or noble gas configuration. So let us look at the molecules, how it is formed by sharing of valence electrons. Let us look for a simple molecule, hydrogen, H2. So the simplest molecule formed in this manner is hydrogen. As you have already learnt, what is the atomic number of hydrogen? First element it is, right? So 1 electron in the K shell. So 2 hydrogen atoms, 1 electron here, 1 electron of other hydrogen will combine together, but it wants one more. It also wants one more to make it noble gas configuration 2. So it cannot lose or gain, so it can attain hydrogen molecule by sharing. So let's take, this is one hydrogen and this is also one hydrogen. So hydrogen having one electron, these two combine together. Together to form by sharing this one electron and this one electron. So by sharing 2 electrons, and in its outermost shell both have 2 electrons. So which is a noble gas configuration, or attained a inert gas configuration. So it is a stable molecule. Like this we can draw a electron dot structure of molecule of hydrogen. Next, like this we can draw hydrogen molecule electron dot structure. Next, or we can represent it is like this with one bond, because one electron pair is shared here. So we can take one bond between the hydrogen and hydrogen. Next, if we see chlorine they gave. So chlorine atom, so Cl2. So one Cl, what is its atomic number? 17. We will write 2, 8, 7. So in its outermost shell 7 are there. It want 1 to make it 8 to attain inert gas configuration. One more chlorine also same. It also want 1 to make it inert gas configuration 8. So both needs 1. So both can share to form chlorine molecule. So chlorine, chlorine and chlorine. So 7 are there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Like this they can share. I drawn only the outermost shell. So one bond will be formed because one pair of electrons are shared. Then next is in the case of oxygen, if we see, it is the formation of double bond we can see. So what is the electronic configuration of oxygen? So oxygen, so 2, 6, because its atomic number is 8. So it wants 2 electrons. One more oxygen if we take, it also wants 2. So 2 oxygens combine. Let's write 2 oxygens combine to form. So how many are there here? So 1, 2, 3, 4. 1, 2, 3, 4. Remaining 2 they will share. Yes, no? 2 pairs they will share. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. By sharing like this 7, 8. So we will get O double bond O. Like this we can write. And one more nitrogen. Let's see nitrogen. Its atomic number is 7. So 2, 5. It wants plus 3 to become 8 octet structure. One more also it wants plus 3. So 3 pairs of electrons it can share. We will write 2 nitrogens combined together, and they are sharing 1, 2, 3, 4, 5, 6. So means 3 pairs they are sharing. So triple bond N. Yes, no? So or else we can write nitrogen. They are sharing 3 pairs. So 3, 4, 5 on outermost shell. Yes, no? Or we can write inside other 2 and a shared pair in the middle. So like this we can represent a electron dot structure of nitrogen. It has triple bond. So how many pairs of electrons it is sharing? That many pairs we have one bond. One electron pair is shared, single bond. 2 electron pairs are shared, double bond. And 3 electron pairs are shared, triple bond. If they ask for example for single bond, hydrogen you can write, right? Hydrogen. Double bond, oxygen you can write. Triple bond, nitrogen you can write. So like this it forms the bond. And next one more example they gave is methane molecule. Same for NH4. Can you draw the electronic configuration of this molecule? So let's draw methane molecule and ammonia molecule, both we can draw. So first is methane molecule CH4. So carbon 6. So 2, 4. So it has 4. So it wants how many? Plus 4 it wants, and this 4 will be shared with along with the 4 hydrogen atoms. It also have we know that hydrogen it has 1 hydrogen. It have 1 atomic number. So 1 electron. So this 1 electron shared by 4 bonds of carbon. So for carbon, it has 4 outermost electrons, and hydrogens, 4 hydrogens combined with this. So it has also have 1 electron. I am representing it with a dot to differentiate both. So this is hydrogens, 4 hydrogens. So like this we can draw CH4. When we next ammonia molecule, so we know that N, its atomic number 7. So 1 is 2, 5. It wants plus 3 to become 8. So these 3 electrons will be shared with the 3 hydrogen atoms. Let's write this nitrogen. So with the 3, it's 3 electrons on the outermost, and 5 are there. 5, okay. It's no. So with hydrogen, 3 hydrogens. So I will represent it with dot. So it will be the molecular structures, and we can write NH3 like this. We can represent. So like this, so many compounds are formed by the sharing of electrons. So such bonds which are formed by sharing of an electron pair between 2 atoms are known as covalent bonds. So covalent bonds molecules are seen to have strong bonds within the molecules. Actually, by seeing that, we can say that they have a very strong bond, but intermolecular forces are weak here. So that's why they have low melting and boiling point. Since the electrons are shared between these atoms, there will not be having any charged particles. Such compounds are generally poor conductors of electricity. Now let's see the difference between ionic compounds and covalent compounds here. So in an ionic compounds, the bonds are formed by transfer of electrons. So because of transfer of electrons, the bond is formed. Here, as we know, now only we discussed sharing of electrons. Because of sharing of electrons, the bond is formed. Then it have high melting points, boiling points because of strong bond. Here low melting point and boiling points because of weak intermolecular forces. It have weak intermolecular forces between the molecules. The forces will be there, that will be not be that much strong. Weak. Here strong intermolecular forces. Then in ionic bonds, ions are formed. Ions means charged particles like anions and cations. Plus and minus charge will be there. Here ions are not formed. Ions are not formed. Then we can say it can conduct electricity because ions are there. It can conduct electricity. It will not conduct electricity. So these are the difference between ionic compounds and covalent compounds. Very easy. These ionic compounds are formed by transfer of electrons, by losing or gaining of electrons. Here the covalent compounds are formed by sharing of electrons. These have high melting and boiling points because of the strong bond present. Here they have low melting and boiling points. Though it appears high strong forces, they are not strong forces. They are weak intermolecular forces. Here ions are formed, so they conduct electricity. Here ions are not formed, so they will not conduct electricity. Like this we can give the difference between these two. And next see the allotropes of carbon. What are the allotropes of carbon? The element carbon occurs in different forms in nature with widely various physical properties. So the carbon compounds are various forms, different forms occurs, and they have different physical properties. If we see diamond, this is the very strongest form as we know, and graphite. These two are carbon compounds only. But why it is graphite is brittle and diamond is very strong? Because the how they arranged is different. How the bonds are formed between the carbon is different. In diamond, each carbon is bonded to 4 other carbon atoms form a rigid 3-dimensional structure. So, one carbon is bonded all the sides with the carbon, 4 sides with carbon, with a rigid. Rigid means cannot change its shape. So, in the 3-dimensional structure, whereas in graphite, each carbon is bonded to 3 carbon atoms in same plane in a hexagonal ray. If you see one carbon atom, so 1, 2, 3. It is bonded with the other 3 carbon atoms in a hexagonal ray. Hexagonal means 6 sides array. So, one of these bonds is a double bond. So, because it has valency 4, 3, it is 3 carbon atoms it is arranging. That's why it is one bond is double bond to make it 4. So, graphite structure is formed by the hexagonal arrays being placed in layer one above the other. So, these hexagonal arrays are like layers one above the other. So, these two different structures, diamond and graphite, have different physical properties. We know that. And even the chemical properties are same. Physical properties are different. So, diamond we know it is the hardest substance we know. And graphite, if we see, it is a smooth and slippery substance. And graphite, very good conductor of electricity, unlike other non-metals than you studied in the previous chapter. Then diamonds are synthesized by subjecting pure carbon to very high temperature and pressure. So, the pure carbon is taken and under the high pressure and temperature, these diamonds are synthesized. So, these synthetic diamonds are very small and indistinguishable from the natural diamonds. We cannot distinguish it whether it is a natural diamond or we synthesized it. So, this is about diamonds and fullerenes. So, these are also one type of carbon allotropes. So, carbon 60 means 60 carbons are bonded together to form a ball-like structure. So, it is called Buckminster fullerene because the scientist who designed this. So, his name was given. The first one to be identified was C60, which has carbon atoms arranged in the shape of a football. So, this looked like the Geodesic dome designed by the US architect Buckminster Fullerene. So, this was named as fullerene after his name. So, this is about carbon compounds electron dot structure. So, versatile nature of carbon. In the next video, I am going to explain. Please give me a message if I want to continue. Thank you.